I'm now going to use the second approach to quantify the free energy of this reaction. So the second approach is basically that sum of the products minus sum of the reactions approach using the free energies of formation for all the reactants and products. So I rewrote my equation already. I'm going to go ahead and write my delta G F's, my free energy of formation for all these guys. So 75 minus 16, 0, 206, and minus 237. Another thing I want to remark on that I didn't put in the last video was just sort of what these numbers mean. You notice that there's kind of some trends here where the enthalpy of formation is positive, the free energy of formation is positive, where it's negative, and the magnitudes are kind of similar as well, comparing those two columns. And yeah, it is because they are related to each other. And smaller values like this negative 286 for the water, negative 237, indicates a more stable lower energy molecule. So you have to put energy into, forming oxygen gas out of the oxygen that comes from water molecules. So that's a higher energy value at 0. And positive values, indicate a molecule that has energy stored in its bonds and can be broken down into smaller, simple, lower energy molecules. Okay, so back to the problem. Let's go through that process again. Taking my products, multiplying all the coefficients times those delta G values. So 2 times 206, and summing them. 6 times negative 237. And that gives me a total of minus 1010. On the product side, I've got 2 times 75 plus 2 times minus 16. And that gives me a total of 118. So then I basically am just taking the sum of my products and minusing and subtracting the sum of my reactants. So the free energy change of this reaction is minus 1010 minus 118, and that gives me negative 1128, and the units on all of these guys were all kilojoules per mole. So let's see how that compares to the other approach. With my other approach, make sure I can see these both at the same time. Yeah, with my other approach, I got a value of minus 1114. So yeah, I would say that these two values are very close to each other. They will usually be a little bit numerically different. And that could be because of slight differences in the data sets or the thermodynamic data, temperature effects. There are reasons why they are often a little bit different from each other. But they're both telling the same story, and that's that this free energy of this reaction is negative, meaning it is favorable and it is spontaneous. And going back to the original reaction, that kind of makes some sense, because even though our entropy term was positive, which is not favorable, that's really overwhelmed by this being a very exothermic reaction. That delta H value is quite negative, so that to me explains why this reaction is spontaneous. And yeah, that's really mostly, if you just look at where the numbers are coming from, a lot of that is coming out of the fact that we're reorganizing atoms into these much simpler water molecules. And as a sort of byproduct, we're creating these polymer units, the acrylonitrile, that are useful for an industrial application.